Welcome to my channel. Today's topic is electric fields. You have learned in the last lesson in methods of charging that a charged object can affect other objects, both charged and uncharged, without actually touching them. As an example, a charged plastic rod can exert a force on another charged rod placed close by. We say that there is an electric field around a charged object. Any charged object placed in the field will experience a force on it. Now, what is a field? Field is a space where force is exerted. An electric field is an area where electric force acts on an object or where electric charge experiences a force. An electric field has direction, which is the direction of the force. Next is electric field lines. Electric field lines. The electric field around a charged object is represented by lines of force or electric field lines. These are the lines along which force acts on an electric field. These are also known as lines of force. These lines have direction. The direction of these lines is a direction of a force on a small positive charge placed at a point in a field. Here you can see that field is radially outward in case of point positive charge, and in case of point negative charge it is radially inward as the direction shows. Electric field patterns. Here you can see electric field patterns due to point positive and point negative charges. Also you can see field pattern due to two parallel metal plates in case of finite field and in case of infinite field. In case of positive charge, as already I have mentioned, that field is radially outward, and in case of negative charge it is radially inward. Lines of force start from positive charge and they end at negative charge. In case of finite field, you can see that field lines are straight and parallel to each other, and they originate from positive charge and end at negative charge. In case of infinite field, the field lines are parallel within the plates, but at the corners they bulge out.